Hello everyone, welcome back to our channel. Let's discuss the next reaction, that is Barbier Wieland degradation. Already we had a discussion that Arend ester reaction. In this Arend ester reaction, we have seen that the conversion of carboxylic acids by increasing the length in carbon chain by 1 CH2 unit. It means that what? If you have COOH, it can be converted into RCH2 COOH. We have increased the length of the carbon chain in carboxylic acid by 1 CH2 unit. If we do the reverse process, that is commonly called as Barbier Wieland degradation. The name itself indicates degradation means reduction in the carbon chain, right? See the statement. Decreasing length of carbon chain in carboxylic acids is commonly called as Barbier Wieland degradation. If you see the general equation, the general representation of carboxylic acid is RCH2COOH. It can be converted into carboxylic acid by decreasing 1 CH2 unit. So how we are going to perform this particular reaction? For that purpose we are using different reagents. The first one is the what? Alcohol in acidic medium. The second one is Grignard reagent. Third one is dehydrating agent. The fourth one is oxidation. Alcohol, Grignard reagent, dehydrating agent and oxidation. If you do 4 different steps, then we will come up with what? The carboxylic acid in which we will observe the decreasing in CH2 unit. Right? Let's see the mechanism. In the mechanism, the starting material is what? Carboxylic acid. The first reagent is alcohol in acidic medium. We all know that if carboxylic acid is treated with alcohol, what will happen? We will get esters or not? This phenomena is called as esterification. The treatment of carboxylic acids with alcohols to form ester. Simply the esterification phenomena takes place. Thereby what happens? The ethoxide ion is attached here. Conversion of acid to ester. After that what happens? We are going to treat the particular ester with Grignard reagent. Already we know that the general representation of Grignard reagent is what? RMgX. Here we are having R minus and MgX plus. In case of phenyl magnesium bromide, what happens? pH minus will be produced. The produced pH minus is going to attack the carbonyl group of the ester. Thereby what happens? Oxygen will take the minus charge and the phenyl group attach it to this particular carbon. We will come up with this kind of anion. This anion is going to again reform the carbonyl group. Thereby what happens? It can remove ethoxide ion. By the removal of ethoxide ion, what is happening? The ketone group is produced or not? Okay? This is the what? If the ester is treated with 1 mole of Grignard reagent. We all know that if ester is treated with 1 mole of Grignard reagent, it can produce a ketone. But in this example, what happens? We are taking 2 moles of Grignard reagent or not. The second mole of Grignard reagent is going to treated with the ketonic group. So the pH minus is going to attack the carbonyl group. Thereby oxygen generates O minus. Then we are having MgBr plus or not. The MgBr plus approaches to what? Oxygen. Thereby we will come up with this kind of space. O minus and MgBr plus. This one is subjected to hydrolysis. If you do the hydrolysis phenomena, what happens? H plus here, OH minus here. So here what will be removed? MgOH Br will be removed. Thereby we are coming up with what? An alcohol or not? This alcohol is what? Tertiary in nature or not? This is tertiary alcohol. This tertiary alcohol is subjected to dehydration by using acetic anhydride. We know that acetic anhydride sometimes used as a styling agent, sometimes used as dehydrating agent. In this particular case, it is used as what? Dehydrating agent. So because of this reason, what happens? Hydrogen from this carbon and OH from this carbon removed in the form of H2O, we will come up with what? A alkene. So we are having different kinds of the oxidizing agents to oxidize the alkenes. So you can use any one oxidizing agents, for example, chromium trioxide. Thereby what happens? The oxidation phenomena takes place at this pi bond. So this can be converted into carboxylic acid and the corresponding ketone. So in this way, we can decrease the length in carboxylic acid by 1 CH2 unit. This is the what? Mechanism of Barbier Wieland degradation. The last portion is what? Applications. If you see the applications of this particular name reaction, in most of the cases, this reaction is widely used in steroids. In case of steroids, we are using this particular degradation. If you see the first example, it is the what? Cholesterol molecule or not. The cholesterol is initially subjected to oxidation. What happens? The cleavage of this bond takes place. It can produce a keto group and acid group. See this one? Here we have two CH2 units or not. The idea is that what? To reduce the two CH2 groups. Right? For that purpose, initially what happens? This particular moiety is subjected to Clemmensen reduction. We know that Clemmensen reduction is used for what? Conversion of these kind of compounds into corresponding hydrocarbons. C double bond O is converted into CH2. Here the same situation takes place. This C double bond O is converted into CH2. Then this is subjected to Barbier Wieland degradation 2 times. First time what happens? The first CH2 unit will be removed. The second time what happens? The second CH2 unit will be removed. Thereby we are coming up with what? This kind of moiety. So why the people are doing these kind of situations? Because this is the structural determination of steroid moieties. In order to identify the methyl group at this particular position, we need to do this following transformation. The second example, see this. Already ester group is present here. See this. First carboxylic acid is treated with alcohol, initially produces what? Ester. It means the first step is already done. So in the second step, what we need to do? We need to do 2 moles of phenyl magnesium bromide followed by dehydrating agent. Here we have used acetic anhydride, here we are using sulfuric acid and the oxidizing agents. So what will happen? This ester is converted into COOH and one CH2 group will be reduced. See this one, CH2 and COOH. If you observe this one, here it is a keto group. This one is what? Alcohol or not? We are using oxidizing agent or not? That's why the alcoholic group is also converted into corresponding ketone. The last example is, here also ester group is present. We are going to take 2 moles of phenyl magnesium bromide followed by dehydrating agent and oxidation. What will happen? The ester will be converted into acid and this CH2 group will be removed. So this is all about your Barbier Wieland degradation. Just you need to remember R&D ester synthesis and Barbier Wieland degradation. R&D ester synthesis is used to increase the carbon chain in carboxylic acids. Barbier Wieland is reverse of the R&D ester reaction. Okay.